Welcome to the ET302 how-to video for Watt's Law Lab. Here we are at part 1A of our Watt's Law Lab, and what we have is a circuit here. And we have a 10-volt battery, a 1-ohm resistor, and we have a voltmeter, which is going to measure our voltage across our resistor. And we have an inline ammeter, which is going to measure our current. This device here is a wattmeter. It's going to take our voltage and current and multiply them and then figure out what our power is in watts. And this is going to use this simple formula, power equals volts times current. And we're going to complete the table and confirm it on multisim. So our battery voltage is going to be 10 volts. Our resistor voltage is 10 volts. Since we only have one resistor, it's going to use up all the voltage. Our current is going to be 10 volts divided by 1 ohm is going to be 10 amps. And we have voltage times current, so we have 10 times 10, which is going to be 100 watts. And we're going to confirm that in multisim with our meter. First thing we need to do is open up our multisim and then take our file from Canvas and put it on the desktop or somewhere you could find it, and go ahead and unzip it so we could get to the files. Or if you're using VMware, go ahead and use the files on our instructor files under ET302. So I'm going to find the files on my desktop. This is the computer version. So let's find desktop, and we're going to use Power Lab. And I'm going to open up the first Watt's Law Lab. Make it a little larger. And let's center it. Okay, let's make it a little smaller. And again, what we have is our 10-volt battery, 1 ohm. We have our voltmeter, 10 volts. We have our current meter, 10 amps. And we have our wattmeter. So let's go ahead and turn our circuit on. And we have 10 volts, one user using up all our 10 volts. So we have 10 volts. Our current's going to be 10 amps. And V times I is 10 times 10, which is going to be 100. Since it's in volts and amps, it's going to be watts. Good. Here we have the same circuit, and we're going to use a different formula. We're going to use power equals I squared R. Squared means we're going to multiply I times I, and then times the resistance. So let's go ahead and fill in the table, and then we're going to confirm it in multisim. So we have the current would be 10 divided by 1 ohm, which is going to be 10 amps. All right. So we have I squared R. So we're going to take 10 times 10, which is 100, times 1 ohm, and it's going to be 100 watts. And we're going to confirm it. So even though it's using a different formula, we're still coming up with the same answer, 100 watts. Okay, let's go ahead and close out of this. Make sure that you turn it off, and we're going to open up Watt's Law B. And here's our circuit. And let's turn it on. And here again we have V times I, which is 100 watts. But in this case, what we're going to do is use the other formula, I squared R. So we have 10 amps times 10 amps, which is 100, times 1 is still 100 watts. So it's working good. Okay, here we have a circuit, 3-volt battery, 3 ohms, and our wattmeter. And we're going to use the formula of power equals V squared over R. So V squared will be V times V. So let's go ahead and fill out our table, and we're going to confirm it in multisim. So 3 times 3 is 9. And then we have V squared over R, which is going to be 9 divided by 3, which is going to be 3 watts. And we're going to confirm that with our power meter in Multisim. Okay, so let's close out of this one. Make sure we turn it off. And we're going to open up Watt's Law C. And there's our program. And I'll clean up all these files for you. Okay, so let's go ahead and start it. And let's open up our watt meter. And here we're going to use V squared over R. So 3 times 3, which is 9, times 1 ohm. So we got 9 divided by 3, which is 3 watts. Since we're in ohms, it's going to be watts. Good.